So imagine looking at your AV rack. You've got multiple 4K gaming consoles, maybe some streaming boxes, and you're trying to route all of that across different displays in your home or your office.
Oh, yeah. And some of those are pristine 4K, but then maybe you've got like that one older 1080p monitor in the mix.
Right, exactly. And suddenly a digital handshake fails, resolutions clash, and all your screens just go completely black. It is the exact nightmare we are solving in today's deep dive.
Yeah, it's basically the ultimate data bottleneck.
Yeah.
And getting past it requires, well, a lot more than just a standard $20 HDMI splitter.
Oh, definitely. So today we are looking at the Blustream CMX44CS-V2 from HDTVSupply. It is a 4x4 4K HDMI 2.0 matrix. And at first glance, I mean, it's just this unassuming metal box with a price tag of nearly $1,900.
Which sounds a lot, I know.
It does. But our mission today is to break down the actual mechanics of how this unit functions as, like, the elite traffic cop for complex setups,
Yeah.
just directing massive digital media perfectly without any crashes.
Well, to understand what this hardware is actually doing, you really have to look at the sheer roads it controls, right? The actual volume of data. It takes 4 independent HDMI inputs and routes them to 4 outputs at 18 gigabits per second.
Wow, 18 gigabits.
Yeah, massive.
And that bandwidth is crucial because it supports 4K at 60 hertz with a full 4.4.4 color space, which, for those keeping track, means there is 0 color compression happening.
Right. Every single pixel gets its own dedicated color data instead of borrowing from the pixels next to it. Pushing that much uncompressed data is computationally heavy.
So to be clear, you could have a live game playing on 3 screens while the 4th plays a movie, and it's all seamlessly managed from this one hub.
Exactly. And the real processing power goes into maintaining HDCP 2.2 compliance across all those active streams simultaneously.
Which is the copy protection stuff, right?
Right. But it's not just a basic label. It's an active cryptographic handshake between your source and your display. If the timing of those encryption keys is off by even a fraction of a second on any route, the connection just drops.
Oh, wow. So the matrix constantly recalculates those keys for every connected device so the signal never fails?
Yep, it keeps the math perfectly synced.
Okay, but what happens when you introduce a roadblock? Say you've got those 3 brilliant 4K TVs, but your 4th screen is that older 1080p monitor we mentioned. Normally, doesn't the source device see that 1080p monitor and just throttle the entire network down to match it?
Yeah, that is the classic lowest common denominator problem.
They are.
But this matrix actually bypasses that limitation using automatic video down conversion.
Wait, how does it do that?
Through EDID manipulation. EDID is essentially the digital ID card a monitor sends to the source, detailing its maximum resolution.
Oh, I see. So instead of letting the 1080p monitor talk directly to the 4K source, the matrix intercepts that ID card. It's almost like a bilingual translator that speaks brilliant 4K to the new TVs, but automatically, dumbs it down to 1080p for the older monitor.
That's a great way to put it.
Or like a high-pressure water main feeding a neighborhood. If one house has old pipes, you don't drop the water pressure for the entire block. You just put a pressure reducer on that one specific house's intake.
That is exactly how the hardware scaler works on each individual output port. The matrix tells the source to keep pumping full 18 gigabit 4K, and then it actively downscales the video locally for the older screen.
That is huge for commercial setups, right? Like a sports bar or a conference room. You don't have to downgrade your entire system just to accommodate one older screen.
Precisely. It isolates the hardware limitation, so your other 3 displays stay at perfect 4K. But, solving that video bottleneck is massive, but pristine videos really only have the experience.
Right. It's useless if the system can't integrate with your audio receivers or your control setup.
Exactly. Which brings us to the audio breakout features. The matrix extracts the audio from the HDMI signal and sends it concurrently to analog and digital optical outputs.
So you can feed a dedicated amplifier without needing all those complex audio return workarounds?
Yep, it simplifies everything. And then there are the vast control options, a list of Web GUI, TCP/IP, and RS-232 routing.
Okay, let me push back on that for a second. Does an everyday user actually need an archaic serial port like RS-232 and a Web GUI? I mean, is this overkill strictly meant for pro AV installers? Why not just rely entirely on Wi-Fi?
Well, it really comes down to absolute fail-proof reliability. While HDTVSupply definitely targets commercial custom installations with this unit, serious home theater enthusiasts rely on this too.
Really? Still using RS-232?
Oh, absolutely. If you have a modern smart home system driven by Control4 or Crestron, you cannot risk a dropped Wi-Fi signal missing a crucial automation cue. RS-232 provides a hardwired, dedicated communication line for third-party control drivers.
Ah, so it ensures the matrix responds instantly when your overarching smart home system fires off a macro.
Right. It engineers a flawless environment so you never actually see the massive processing work it's doing behind the rack.
Wow. When you view it through that lens as a system actively negotiating cryptographic handshakes, intercepting EDID data, and communicating flawlessly via hardwired serial, that $1,895 price tag, which by the way includes a 5-year warranty, makes a lot of sense.
Yeah, you're not just buying a splitter. You're buying an intelligent manager that wrangles diverse resolutions and audio formats into submission. You're buying total network stability.
Definitely. Which leaves you with one final thought to explore on your own. If it requires this level of highly engineered processing power just to manage the perfect routing of 4K streams today, how complex will the matrix hubs of the future need to be when our homes are blanketed in dozens of uncompressed, data-heavy 8K displays?